There we go. Goodness. I was going to have to go different here for a second. Give me 1 second. I had to switch the stream up. Good. My apologies to those who got into the other one before me switching it over here. All right. Should be good here. Okay, cool. Sounds good. Sounds good. Hello. Hello again. Hello again. Yeah, when I had to start with this, when I hit start stream, it told me live streaming isn't available right now. My goodness. Um, all flustered now. Sound. All right. Hello. 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 Hi, Dimitri. Hi, Dimitri. How's it going? How's it going? Um, yes, April 20th. April the 20th, 2020. My goodness. We are in almost the tail end of April now. We've gotten over that middle part of April, and now it's coming down towards the end. I can't believe we're already here. I think it's what day 30 or 40 something of you know, being home, being on quarantine. Um, but needless to say, I'm going to talk a little bit about ratios today. I'm going to talk a little bit about ratios. Um, those of you who by chance want to follow along with me, I am in Pearson Realize. I am in Pearson Realize. Obviously, PearsonRealize.com. When you get into there and you sign in, I will tell you exactly what we'll be going together with here very soon. But for right now, I want to kind of bring up this little question that we have here. Um, if you were given this question, so you see here, it says a band just released an album that contains both pop songs and R&B, or what we call rhythm and blues songs. And you see this little breakdown to your right, this little chart to the right, and this is the best of the 90s. Some interesting choices here where you got British pop and chamber pop. Trying to figure out exactly what chamber pop is. Then you see dance pop, dream pop, electro pop. Some very interesting choices there, especially on R&B when you see Motown and psychedelic soul and soul blues. My goodness, some very, very interesting choices here. Um, Here's the thing: the question that this is asking you, it's saying, go back to the first part. So he said, well, how can you describe this relationship, the relationship that you see between the number of pop songs and the number of R&B songs on the album? Now, because this because this specifically has a tool this specifically has a tool for doing this. So I'm going to use my tool here. So what do we use when we want to describe the relationship between something and something else? So we're describing a relationship between the number of pop songs and the number of R&B songs on the album. Well, if you remember to kind of, shake off the early morning cobwebs and all that kind of good stuff, that is what we like to call in the math world a ratio. That's a ratio. And we deal with ratios all the time with, in life in general, ratios when it comes to making some kind of food, or you're trying to figure out, well, how much do I need to get X, Y, or Z? I mean, there's ratios, all around us. So in this specific instance, we're trying to describe that relationship. So if you remember, this will be in the packet. This is actually topic five. Topic five. If you look up here to the left, I'm going to kind of go a little different here. So this is topic five, way up here in the packet. What I'm trying to do here, this will be in actually topic five, which I'll get to here in just a few minutes. What this is for us need to break off the cobwebs so that we can then get further into that. Okay. So the question on this is, well, how can you describe that relationship between the number of pop songs, number of R&B songs on the album? We use a ratio. There's three ways to write a ratio. There's three ways to write a ratio. One, go back here. So the three ways that we want to write that ratio would be, we have x to y, we have x colon y, and then the third way is, looks kind of familiar to, hopefully to everybody, is x over y. Now when I say x to y, it means one term. This is a term compared with another term. Okay, so you're comparing two terms to each other. So how can you describe the relationship between the number of pop songs and the number of R&B songs on the album? Well, take a look. How many pop songs do you see? How many pop songs do you see? You see 9 pop songs. How many R&B songs do you see? You see 6. You see 6 R&B songs. Now, here's the thing. If you wrote that ratio as 9 to 6 like that, it's not technically not correct yet because you have to actually reduce that ratio. You reduce that ratio by figuring out what number, as if you remember from our fraction here, what number can be divided both into 9 and 6 both evenly. So you go through and your answer to that is going to be the number 3. Okay, it's going to be the number 3. So when you reduce this ratio, you say, well, how many times can 3 be divided into 9? 3 can be divided into 9 3 times. How many times can 3 be divided into 6? 3 can be divided into 6 2 times. So your reduced ratio on this is 3 to 2. It's basically saying, and what let me kind of erase the screen because I got a lot here. So remember 3 to 2. Now let's delete all. Our ratio is 3 to 2. What this is telling us right here is that for every 3 pop songs that you see, there are 2 R&B songs. So 3 to 2. Okay. So then the question becomes, well, we can then come up with an equivalent ratio. And this is where, hopefully, this looks a little more familiar. If we were to use this description of how to write a ratio, 3 over 2. What's up, Trevor? How you doing, man? So if you use that comparison right here of 3 to 2, okay, 3 to 2. If I were to say based on that ratio, how many pop songs, let's do it this way, 3 pop, that's 3 pop, 2 R&B. If I were to say on this, well, how many pop songs would be created if we had 12 R&B songs? So if we had 12 R&B songs, you can figure out by saying, well, 2 times 6 equals 12. What you do to the bottom, to the top, 3 times 6 is 18. So based on that same rate that we're doing here, that same ratio, that same rate, you can figure out based on what you see here how many of a certain term can be made if, say, like I could sit there and say, well, how many pop songs would get created if there were 400 R&B songs? And you can do the same. You could do this same little math scenario here, where you're trying to find your equivalent ratio with being able to try to find that. So, but that's just kind of breaking that part down there. I mean, now I will tell you though that the book gets into another way of showing it visually, and it's called a bar diagram. And as you see right here, best way for me to explain this is to say that, well, each specific bar, each specific bar right here is supposed to represent three songs, three songs, three songs. Because there's 9 total pop songs, there's 3, 3, and 3. R&B would be 3 and 3. You kind of see how there's each bar represents each bar represents 3 songs. Each bar represents 3 songs. So when you break this down, it is again 3 to 2. Again, the bar way of doing it is kind of, in my specific belief, is a little bit. I always like to use the term kind of a little bit wonky, but um, it's something to where you have to kind of know it. I mean, you have to know it to where it's like, each bar is going to represent something. So you say to yourself, well, what if we had, let's see here. So if each bar represented 3 songs, you'd say, well, what if we had 2, 3, 4, 5 bars here? So if each bar represented, each bar represented 3, 3, 3, 3. I mean, you see the correlation here. It's the same. It's the same way of just how we did it on the front part here too. But definitely the 3 ways to write to write your ratio here. I mean, again, is use the word 2, so 3 to 2, 3 colon 2, or 3 over 2. This one right here, that 3 to 2, that 3 to 2, that 3 to 2 right here. I like to use that one when it comes to explaining fractions and when it comes to finding equivalent fractions, because it goes the same way with that. Again, hope that kind of makes a little bit of sense. Hope that makes a little bit of sense. It kind of explains a little bit about ratio, equivalent ratio. Again, you do what's best for you. You do what's best for you to be able to find out, to get the right answers. Ratios, those will stay with you for the rest of your life. If you realize you've done ratios throughout your lives already, if you've made any type of food, or you're trying to put them, or in like a science term, where you're sitting here and saying, I have 3 parts, 3 parts nitrogen. I'm just making this up, but a certain chemical compound, 3 parts nitrogen for 4 parts oxygen. I mean, you have to find out the chemical compound that gets made when you expand it out. I mean, there's many, many, many ways ratios are part of your daily lives. But that's enough for that. I am going to get into packets that you guys received here. So again, I'm going to bring this up. Give you guys a second to bring that. Yes, ratios are so bad. Oh man. Bring up my information here. So like I said, I am in topic 5. So just to kind of stay with what we're kind of talking about here. My apologies for the nauseating ride down this here. So let's start. We start with, and for those who were with me last Tuesday when I explained this, know that these packets, hopefully, and I hope these all at least somewhat familiar. I will do more of this tomorrow too. So when it comes to doing this, just know that it explains everything that we've at least tried our best to go over. Obviously, time permitting, time constraints, all that kind of good stuff does affect things throughout the year, and especially being out of this school since March. So we make the best of what we can. So just know that if you see here, the quick review tells you about how to answer these. And it does give you an example too. So you see your example. Remember, I was talking about this little bar diagram, which, I mean, again, I like to keep things as simple as possible when it comes to this. Just get the right answer, to get what you need to do to get the right answer is what matters. So anyways, let's get right into this. If if you look at 5-1, so the understanding ratios, you look at this, a florist uses 5 red roses for every 2 white roses in her bouquets. And just to kind of reiterate, this is page 324, I believe. Yeah, this would be 324, but again, these should be put together. So again, topic 5. So it's, and you're in your 5-1 right here to make sure everybody's kind of going with me here. So a florist uses 5 red roses for every 2 white roses in her bouquets. So the question is well, let's write the ratio of white roses to red roses in 3 different ways. Key thing with this, everybody, write the ratio of white to red. We're going white to red in the 3 different ways. Notice up here, it's written as red, it's going red to white. You have to flip the 2 numbers with this. You have to keep, when the question is asking you to write it that way, you have to keep it that way, the comparison that specific way. So white to red, the 3 ways of writing this is, well, we have 2 white, so 2, 2, 5. The other way is 2:5. And then the third way is our fraction, 2/5. Again, those are your 3 ways of writing. Again, you have to keep this, I can't stress that enough. If I remember, a lot, that seemed to be kind of like the biggest issue when we were going through that before. Just to know that you have to keep it in the same verbiage. I always like to use the word verbiage here. You would want to say, well, if it's saying write it as white to red, you have to put it as white to red. You go, well, it says red to white in here, so I'm gonna keep it as 5-2. No, you have to write it in the same way that you see here. Okay. Let's go to number 2. So we say, well, write the ratio of red roses. So let's change color of red roses to the total number of flowers. So the question on this is, well, and I would hope we kind of understand this to the most part. How many red roses do we have? We have 5. We have 5 red roses. What's the total number of flowers? The total number is 7. So we have 7 total. So the ratio of red to total is going to be, well, 3 ways, or 5:7, 5:7, and 5/7. Okay, so that's the three ways of writing that. Okay. Number 3, if the florist uses 10 red roses in a bouquet, how many white roses does she use? This is now where we go into the equivalent ratio. Now I'm going to try my best to leave that other stuff on up top. So I'm going to change the color to be able to show the difference here. So if the question tells you, well, if the florist uses red in a bouquet, well, how many white? What is your ratio? Your original ratio is 5 red to 2 white. So 5 red to 2 white. So what would happen if they used 10 red? 10 red in that. If they used 10 red in this, you say to yourself, and you say, well, I'm going to go, well, what's 5 times what is going to give me 10? 5, or what's 10 divided by 5? 5 times 2 is going to give us 10. What you do to the top, to the bottom, 2 times 2 is going to give us our answer of 4 white roses. White roses. Okay. Again, that's equivalent ratios. And it's trying to find, it's expanding it out. You can take that out and say, well, what if the florist uses 50 red roses in a bouquet? Well, how many white roses? Same thing. You're expanding these things out. Number four, if the florist uses 10 white roses in an arrangement, how many red roses does she use? Again, up. So 10 white. So we're going to go white to red in this. It's telling us as we went here, 10 white roses, we're trying to find out how many red roses. What is our ratio of white to red? White to red is 2 to 5, so it's 5. That's a 5, by the way. So 2 white, that is supposed to be the word white, sorry, for 5 red. You keep your, I can't stress this enough too, you have to keep your terms in the same setup that you have. So in the question asks you if the florist uses 10 white, how many red? 2 times what is going to give us 10? 2 times 5 is going to give us 10. What you do to the top, you do to the bottom. 5 times 5 is going to give us 25 red roses. 25 red roses. Okay, I know it's a lot of writing on the on your screen in front of you there. If you're like me holding a phone too, I try to use the phone to see exactly where my face shows up when I do bring up my head right there. Again, this is ratios, equivalent ratios, all that kind of good stuff. Um, Hope that kind of makes a little bit of sense. And it's just it is a review. We talked about that way back. That was one of the first things we both between intervention and in my area you guys had went over. Um, but yeah, let me try to get a little bit of the next section and then we'll go from there. Let me clear the screen and then we'll scroll down here. Okay. So equivalent ratios, just how we were just doing it here. How you can multiply or divide both terms of a ratio by the same non-zero number to find equivalent ratios. It's the same exact thing that we just did up there when it came to how many white roses, red roses, all that kind of good stuff. And it gives you an example, find two ratios that are equivalent to 21 over 126. And it tells you you can multiply to give you an equivalent ratio, or if you know the other terms of what makes it up, you can divide. Again, if you remember me talking about the correlation here, when finding equivalent ratios is also about reducing fractions. Reducing fractions and finding least common, or finding your greatest common factors and all that kind of good stuff. It all kind of meshes together, which is always an amazing thing. So let's take a few of these here. So it says in 1 through 4, it says find two ratios equivalent. Equivalent to the given ratio. So if we have a number 1, so let me kind of go right up here with number 1. So if I have the ratio of 5 over 12, make this as easy as possible for an equivalent ratio. Don't go, well, I'm going to go 4 times it by 4 or 5 or 6. Multiply it by 2. Multiply it by 2. Make it easy on yourself. An equivalent ratio here, multiply both the top and the bottom by 2. That equivalent ratio is going to be 10 over 24. By, another way is multiply each top and bottom by 3. 5 times 3, you do to the top, you do to the bottom as well. 15, 36. mean, you can continue going with this and say, well, again, it's what you do to one side, or what you do to the top, you do to the bottom. You could take any of these here, 1536, 2048. It's kind of kind of self-explanatory in a way, but if you know anything about reducing fractions, I mean, it should be very easy. So let's clear this. I'm gonna get one more here before we call it. So number 5. So number 5 on this. For every four bagels sold at a bakery, 7 muffins are sold. It says how many muffins are sold in the bakery? Sells 24 bagels. So you want to make this easy on yourself to answer the actual question on this. Answer the actual question. You have to say to yourself, 4 times what is going to give us 24? Take 24 and divide by 4. You're going to find that it's getting multiplied by a factor of 6. So 4 times 6 is 24. You're then going to take that 7 on the bottom and multiply it by 6 to give you 42. And then you can figure out to fill in the other parts of this, to figure in the other parts of this, you use that same way of doing things. Multiplied by a factor up top. The top you do to the bottom. With that being said, tomorrow I'm going to go through more. I'm going to go through more of this. Let me kind of clear my screen a little bit. Clear my screen, but yeah, I'm going to go through more of this topic 5 tomorrow. Questions with anything, always feel free to reach out. With that being said, I will cut this short here and be setting myself up for 7th grade. If you have any questions, reach out. Otherwise, have yourselves a good day.